This is the Absolute Business Mindset podcast. This is created and hosted by Mark Hayward. I am a corporate employee with an entrepreneurial mindset. This podcast will help and support you with new ideas about business. These are my thoughts, ideas and comments. Today I'm talking to Richard Abbott about AI and business and tech. Hi everyone, this is the Absolute Business Mindset podcast and I'm here with Richard Abbott.
Hello, this is Richard Abbott here.
Excellent.
Yes.
Just to give you a bit of a background, so Richard, I worked with Richard a little while ago, and where he was a tester in our technology area of the business. We struck up a friendship, and I thought it would be really interesting because Richard's got quite a lot of background within AI in the 90s, as well as a lot of different understanding of business and industry and technology. So I'm going to talk to Richard today about some of his things that have happened in his career, and hopefully you'll get some benefit and you'll get some insight into different areas within technology. And actually he's doing something very different now as his sort of next career, and we'll touch base on that as well. So the first thing, when I was doing my research on Richard, I was surprised that when you look through his education, lots of maths sort of qualifications were there, and then took a very sideways step, it appears to me, to do a PhD in ancient languages. So what was the inspiration between your education, i.e. in maths, but then why ancient languages for a PhD?
Yeah, if you go back to the maths side, I was one of those people who could just do maths, and I'm well aware that there are some people who just can't do maths, and there's a lot of debate goes on in education as to whether some people actually can never grasp mathematical concepts, or whether it's just a matter of appropriate teaching and finding the right teacher for the right pupil. I was one of those people who could do it, so I went on from school into university, and then into ultimately a PhD in theoretical physics. But I was always at the mathematical end. I couldn't do an experiment really to save my life. And the kind of theoretical physics I was involved with turns up in some of the most groundbreaking developments at the moment, things like early universe research, gravity. There's been a lot of scientific interest recently about black hole pictures and that kind of stuff that probably people have seen in the media around about this time. Yep. However, I kind of got slightly, not disillusioned with that, because I enjoyed it, but I realised that within my lifetime I wasn't going to be able to build a Starship Enterprise warp drive or something like that. It felt very abstract, and I wanted to be doing something that was much more hands-on, much more relevant, I suppose you could say, which ultimately, just leaving aside the languages stuff for the moment, ultimately led me into IT as a career. I've been a developer, I've been a tester, worked with small teams and big teams and as an individual. And that, because of the AI that we're going to touch on later, that actually uses a lot of the same mathematical ideas and formulae as the stuff I used to work on years ago. So there's a very, very interesting crossover between sort of early universe physics and AI research.
So I'm probably in the camp of the people that can't do maths as well as probably almost definitely as well as you could. So it's interesting you were saying about maths. So do you think it is binary? It really is. Some people brains are more geared towards understanding maths and being able to do maths rather than where I started with humanities, so all my education has been in the humanities area rather than mathematics.
I'm in the camp that says that actually anyone can learn it. Friends of mine who I respect are in the opposite camp, and that's fine. I actually believe that a lot of it is to do with encountering the right kind of teacher for your learning style. Different people have different learning styles.
Yes.
And I think if you approach somebody with the wrong kind of presentation for their learning style, first it's going to turn them off. They won't see it's useful or relevant. And secondly, they won't grasp it. And I think maths is one of those subjects that you can very easily turn people off. And you get very, very bright people who simply don't see the point of it. They don't see the relevance.
But I think you make a really good point. So ways of learning is a really interesting concept because some people are doers, some people are readers, some people listen to things better, some people watch things better. So you think because I always think now that I can kind of learn anything, and if I have the right conditions, I would be able to learn anything. But that's all probably within the sort of business arena, which is less theoretical. A lot of it is a pragmatic. You've got to be able to think through situations. But are there similar processes, similar mindset that you need if you are going to succeed in maths?
I think so. Maths itself is split into a sort of pure side and applied side. Pure maths is not my arena. Again, I've got friends who lap it up, love it. I was always on the applied side. So for me, there has to be some kind of real world problem that the mathematics is addressing.
Right.
Some people just delight in it for its own sake, and it becomes then a kind of art form rather than anything else. For me, maths was more of a language that you could use to address particular problems, which is, we'll get onto languages in a moment.
Yeah.
But yeah, I had some experience coaching young people in maths a while ago, and found that with particular people, they needed to have an actual problem that made sense to them, rather than sort of, square on the hypotenuse of the sum of the squares and that sort of thing. If you said, well, look, James Bond has to throw a hand grenade into that corner of a room, what angle does he do? Yeah. So then you're actually learning angles and Pythagoras and all that kind of stuff, but in a sort of gaming concept. Yeah, so it's the context of it. So if I was to learn, do a degree in maths from my starting point, you think if it was contextual and the context interested me, there would be more inspiration with mathematics? I think right teacher, right context, and like any subject, there are bits you've just got to kind of, work through, and they're difficult. I found maths quite easy, but nevertheless, there were bits of math that I would say are profoundly hard, and I used to get into, having to read articles, and I thought, this particular subject is one that I'm never going to grasp. Oh, really? Yeah, absolutely. Oh, really? Okay. I can remember one particular physics paper written by some French women at one of the senior French universities in Paris. And I read that paper, must have been 20 times. I thought, this is supremely good stuff. I'm not going to get it. Right. Because they were a little bit too much on the pure side for me. I couldn't quite see how to connect it, how to join the dots. Other things were fantastic. So even within maths, there are subject areas where I would say I couldn't go there. Okay. And other areas I could. Yeah. Okay. That's interesting. And so you grew up within the maths arena sort of education, and so did the PhD come in ancient languages come at the same time, or was that done at a much later stage? No, the maths PhD, the theoretical physics one, was at the sort of normal age when people do that sort of thing, early 20s. Yeah. I had a long break then from academic life while I was doing other stuff. Had children, spent a lot of time, as all parents do, on child-related activities. Yeah. They grew up, left home, did their own thing, and then I wanted more intellectual content. I was in a job at the time that was that wasn't very intellectually stimulating. Okay. This is well before you and I knew each other, and so I undertook the languages side, which is a kind of mixture between languages and ancient history and literature. Yeah. So it was a kind of crossover PhD. And I did that part-time as a distance learning student. So it took me about 6 years to finish. Right. Quite different model, going in as a mature student into a part-time learning situation. Yeah. It worked for me. Okay. And the languages connection, with languages both ancient and modern, I love finding out how they work, why they're different, why, let's say, Arabic or Chinese as a language works in a different way to French or English or German, so different language families. What I am desperately lazy about is vocabulary. Okay. So I love finding out how they tick, but you put me in that country and I struggle. Oh, so if you do you think you could you learn French, Spanish, or German
relative? Could you get by? Do you think with your language
those
knowledge?
three, yes. And
But
when we were
something
on
like
holidays-
Mandarin.
Yeah, I did actually. There was a period in my life I was working with the Chinese team in IT in the southern part of China. Loved the experience. Had a great time with them. And anyone who's worked with Chinese IT teams will know that they have a huge emphasis on learning English. They have days in their office where they are only allowed to speak English, for example.
Right. Okay. Yeah.
And you think, well, if we had that commitment here in the UK to learning languages,
Yeah.
where let's say at the office of name a company,
Yeah.
we were only allowed to speak Arabic or only allowed to speak Chinese, you'd learn it pretty fast.
And that's a really interesting. It's a really interesting point. There's someone who's joined our team fairly recently from Brazil, and she was given the example of learning English, and so she learned English at school. She then. What I hear lots of people say, she then started watching English TV or American TV and radio to pick up language that way, and then she then did a full-blown English course. But she was saying that even now, and with Brexit and things, that there might be differences happening, but still the language of business is always English, whether you're travelling to Hong Kong or Brazil or Germany. If you're sitting with a global team, you will speak English. So we've both had experience of working with an Indian team, and they spoke all English. And to be honest, their English was fantastic. I think there's not neither of us could say there was an issue, but I think you're right. There just isn't the commitment to languages in the UK, and I think that's because they're lazy. Because
a little bit of Bengali when I was working with Indian teams, but never enough that I could communicate meaningfully about technical subjects.
Right. But you could have a.
I could say, hello, how are you?
Yeah, right.
I'll have one like that, please.
And so you spent quite a lot of time in academia.
Yeah, I suppose so. Yes.
In two or three stints, depending on it. So moving on from there into sort of conceptually, one of the things I was reading about you was that you enjoy problem solving.
Mm-hmm. Yes.
And because I'm quite keen on talking to people about their skills and techniques that they use in business, how would you say you approach a problem, or how should anyone that's listening to this approach a problem and be as efficient and as effective as they can be?
I think there's a huge tendency in any area. You see it in IT, you should see it in business. I see it in my current role, which is within the context of a very practical family business, where people do something because they've always done it that way.
Yes.
So there's an inertia. And part of problem solving is saying, why do we do that? What was the original motive that made this seem like the best solution? And maybe it was the best solution 5 years ago. Let's be charitable and assume it was. Why do people think that's still the good solution now? Well, partly it's inertia, partly it's there's a vested interest of an organisation or of individuals within that they have a particular role which they like and they're comfortable with.
Yeah.
Part of problem solving is actually before you ever get to writing a line of code or appointing a person to a role, whatever is the action that you take. Part of problem solving is saying, what are we actually trying to do and why are we doing it? And I suspect in any business, and certainly in every computer program, you will find a fair proportion of stuff that goes on because it made sense once and has never been removed.
Right.
I'll give you a very practical example about that. One of the businesses, family business I helped run as a guest house, and it had over the years all kinds of television technologies installed in it. We currently use streaming off Amazon Fire Sticks. Fantastic, wonderful. A bit confusing for some people, but fundamentally it works. But when you looked at the outside of the house, there was this kind of almost a net of old TV cables draped all over it.
Yes.
Which were dead, because they weren't actually connected to anything, but nobody had gone through saying, we don't need this wire, let's cut it off.
Yeah.
And you find that with computer programs, that there's something which made sense, it was a piece of functionality that was required at one stage, became obsolete, but whoever did the coding took a kind of, well, we're not quite sure what it does, so we better leave it. Yeah. And so that idea of we better leave it puts then a burden of maintenance, a burden of understanding, a burden of testing, and in business sense, at all costs. So there's a cost associated with all this kind of dead functionality that you're dragging around. Often in programming circles, you'll hear that called technical debt.
Yeah.
Fundamentally, it's stuff that you no longer want, but has never been cleared up.
So there's a difference. So these sorts of examples are things which are incredibly valuable, because there are, as I say, there's a lot of things in business, in technology, that, as you say, has been done for the last 10 years and it will continue to be done. Yeah. And that's wrong. And we should be challenging ourselves throughout your development in a career or a business to challenge the status quo, because things change, people change, roles change, people leave, regulations, exactly, legislation and things change all the time. So we should be challenging ourselves. Is it a mentality of if it isn't broken, let's not try and fix it? Do you think in most cases?
Yeah, definitely. And I understand that, and particularly from the business side, there being a techie in business companies, there's a continual tension between the business side wanting things to cost less. So a new initiative, someone will say it'll take you 6 weeks and 40 people. And the business will say, well, it has to be done in 3 weeks with only 10 people. And you have some horse trading, you come up somewhere in the middle. And it's kind of classic of a lot of technical departments that how much the business are going to knock off. So you inflate your figures a little bit.
Yes.
We think it's actually going to take 6 weeks, but let's say 10.
Yeah.
And then you end up at something that's reasonable. So there's definitely a cost pressure to say, right now, let's just do the minimum piece of work. And that's a theme I want to come back to later on as well. But every choice like that ultimately ends up costing somewhere, because you're carrying along a body of code. Sometimes there are accidental interactions between things that you thought were separate, but actually they're tied together because of some weird design choice that was made.
Yeah.
I'd say that, and obviously I come from the technical side, and I'd like the technical solution to be good.
Yeah.
And the business side typically wants the technical solution to be good enough.
Yeah.
And that's the tension, whether it's good enough or whether it's actually good. Problem solving, I'd say half of it is that. A review to say, what do we actually still need? There was a trend with software a while ago that you packed it full of features. I remember having a lot of conversations with you and where we both used to work about how things were feature heavy. Oh, look, I want a button that when I click it, makes this pink button go blue or whatever.
Yeah.
Nowadays, there's a trend to say, well, let's keep things very lean so that people are guided through a process of what they're doing, and that what they can see on the screen is exactly and only what they need to do at that point of time. So there's a change in mentality about this. But often what you find is that all people have done is they've kind of reskinned the front end. They've changed the web page or the whatever it is, the dialog box. Behind the scenes, all the code that used to do all that funky stuff is still there.
Yeah.
And there's a potential risk. You could end up with security risk. You could end up with unexpected failures. You could end up just with extra cost of testing.
So because I always think about approaching a problem. Sometimes you're not even sure that it is a problem. You just approach a situation, and I think with how you've described things is that it should be a constantly evolving process of making changes, reviewing, if it was talking about code, reviewing the code, tidying it up, because at 6 months down the line you could find that something is impacted with this redundant code which is still linked somewhere. And I think that's a valid thing that we've all experienced. But what I just want to just settle on this sort of problem solving piece is that's very specifically when people don't even know there is a problem. If someone knows there's a problem, i.e. from my side, from the business side, it could be a person, it could be an interaction, it could be something's wrong with a product or a service. When you're approaching that where you actually know there's a problem, is that harder? Because what you're challenging in the other scenario is the status quo and how we get that and keep on evolving and moving forward. But actually, when you're when you know that there is a problem, how would you approach that?
I think it's a really interesting question. I remember somebody once saying to me that a technical problem can always be solved. No matter how long it takes you to write the code or whatever it is. I mean, you can obviously think of examples that's not quite true, but as a broad generalisation, if it's a coding problem, somebody will solve it. If it's a human problem, then that can be very different. You get all kinds of human interactions, which are positive, negative, mixed, varying through time. I've had experience, I'm sure you have, of where we had this is at an engineering firm I work with. We had a very big, very flourishing team. Took on one new person, and it was kind of a disaster. They didn't really want to do the work we were doing. They wanted a much more academic job, and in fact they left to go into an academic job after a while. So they didn't really click with the team. They didn't integrate in a friendship sense. They were very, very good at their job. They could knock out code. Some of their code was, in a sense, too clever. They were a great believer in writing clever, compact code, whereas I'm a great believer in writing boring, simple code that other people can understand. They were very flash with their coding, and it was excellent, but it didn't gel with the way the team was.
Yes.
And we had a lot of difficulties of how do we solve this problem? And as I say, in the end, the problem solved itself. This person went off into an academic job, which is what they wanted. And we all kind of breathed again. Had that not happened, how would we have solved it? Well, I suppose it is easy with hindsight. My preference would have been to have found a different team, to have moved that person sideways.
Right.
I know there's in business there's different mentalities. I've heard people adopt incredibly ruthless sort of strategies. There's a person, let's get rid of them. And you have all kind of analogies about people in a rowboat with the oars going the wrong way and all this kind of crazy stuff. I am fundamentally optimistic about people's participation, and my normal reaction would be, how can we reintegrate that person?
Right.
Or how can we put them in a role, in a job position, or with a group of people that works rather than not working? So I always see actually getting rid of the person as a kind of last resort. And a sign of failure, really, if you have to get rid of someone.
It is, and when I was in the business around 08, 09, 07, 08, 09, there was an ambition for a lot of companies to cut people, and when we had, so there was a deep recession that we went through for any of you younger folks, and our business, or when I was working there, took the position of that we're going to make a set redundancy, and they did make people redundant, but their ambition was always to keep as many people, and being such a big, large corporation, they were able to move people to other parts of the business that flourish in recessions, that don't flourish in the better times. And when you're in that fortunate position of working for a corporation, there is that ability to be able to move around, which I think is an advantage. I equally know some people that were in the building industry, and they were told that they had to cut down to 3 days a week. So these were quantity surveyors, and these guys had mortgages, had families, and they were all told that, what would you prefer, to leave and try and find another job, or work 3 days a week? And I think anyone who knows the industry, construction industry, knows that when they are basically on the front line of recessions, and so they basically stop building when there's no money, and it only picks up when the better times come. So a lot of them took the 3 days a week and remortgaged and things like that, which was the sensible idea. And I suppose, so I'm just going to talk a little bit about the different roles you've had in the different industries that you've worked in, because all the way from academia to you said an engineering firm, so in a way you've kind of, so you worked for Big Four with me, you kind of in a way reinvented yourself a little bit in slightly different industries and different roles.
Yes.
There probably was a theme on testing and development, but it actually takes quite a lot to move from one industry and reinvent into a different industry. What were the motivations? How hard did you find it?
I think as a developer / tester is easier because the domain knowledge you have is of coding strategies, styles, languages. And a piece of code that's written in an engineering firm and in a finance firm look pretty much the same.
Right.
I could drag
because it's the same
bits
language,
it's
it's
the same
C#
language,
or
that's
Java,
right.
etc. You're right.
If I pulled out kind of 50 lines of code from what I wrote within aerospace and 50 within what I wrote in a Big Four context, unless you knew the context I was written, you would have a hard job telling which was which.
Right.
So for somebody who's a technologist, there is less of a problem.
Right.
Definitely, and I've enjoyed that. Now, I know people who've stayed in the same industry for decades. I haven't. I've always moved around.
Culturally, do you find it different?
Totally.
Yeah,
Totally.
I would imagine it would be very different.
I moved, my early IT work, my first IT job was for a very small firm on Poole High Street, down in Dorset.
Okay.
And basically we just did software job shopping. Somebody needed a bit of work done, we did it, and and the guy who ran the firm built it up and was very, very successful. I've got a lot of admiration for him. And he moved with the technology times and with the kind of demand that people were having. I'm absolutely convinced that if he's still running the company now, he will be into cloud computing and all the other buzzwords of the day. Because he was always one who wanted to stay with where the leading edge was of that.
Right.
Now, I went from there into AI work, trading on my maths background, which I loved, and I think we're going to talk
we are going to talk about it.
later on. And then into aerospace, which was very closely connected because the kind of aerospace, I never wrote systems that actually go on board planes. That's an extremely specialised and very, very mission critical thing where the standards for writing are extraordinarily high and appropriately so. I was in what they call third line, which is basically your plane lands, what do you need to do to make sure it's okay to fly again?
Okay, yeah.
So the kind of holy grail for all that is that as the plane is coming towards the runway, it's talking to a ground station which says, "Oh, I'm a bit low on oil, and the carburetor's knocking a bit, or whatever it might be."
Yeah.
And as it taxis up to the thing, the engineers are already running out with the right tools and the right spare parts.
Right.
Refit it, off it goes again.
So how would you? So you would. I'm just fascinated by how you would code something that. So there would be a point where it would make an assessment of what the plane was,
basically,
the status
any
of it.
plane at all, civilian or military nowadays, is every single component of that is instrumented, and so you get kind of like certainly megabytes, probably gigabytes of data from each and every flight.
Right.
Far too much for anybody to just sit and look through by eye. So there are a lot of learning algorithms. The AI came in again there.
Yeah.
To basically say, look, this pattern is a normal one. This engine is behaving within normal parameters. That's fine. This one, on the other hand, there's a lot of vibration noise. In our experience of the past, this means that the clutch is starting to fail.
So was it a sort of flow chart for my simple mind? Was it kind of like the logic that you were building was a flow chart? If it does, if engine does this, it can either do A, B, or C, and then it goes to the next point and the next point.
We actually had a more kind of visual interface. If you imagine on your computer screen, let's say you had a picture of a plane. Let's take the Eurofighter Typhoon, which I now see regularly over the Lake District. So you'd have a picture of that, and then as the thing lands, you would basically get a colour-coded thing. Wings green, right aileron flat red, port engine orange. Engine green.
Right, yeah.
And that would also take into account all of the regulatory scheduled maintenances. So obviously with an aircraft, and particularly with a helicopter, where I also did some work, the requirements for routine scheduling are very, very strict.
Yeah.
It's not like your car where you think, maybe I'll do a service this month.
Yeah. You can't do that. You got people's lives on
Exactly. So all of that goes into it, and some of it is just regulatory scheduling. Some of it is analysing the signals that come off it. Vibration signals in particular are very, very thick. You could use that same kind of thing for trains. I worked on trains at one stage for wind turbines, because a wind turbine is kind of like a propeller on its side.
Yeah.
And so that idea of analysing vibration traces to say this is normal, this is abnormal,
Right.
and then what do I do about it if it's abnormal?
Right.
So decision support.
Yeah.
I loved all that, as you can probably tell, and I enjoyed working in engineering because there was a sense in aerospace particularly that you're working on something which you expect to last a lot of years. We worked on aircraft systems which were first flown in the 1950s,
Okay.
was still flying, still qualified to fly. You don't get many industries where a sort of 50, 60, 70-year-old item is still fit for use.
Yeah.
And I love that sense. And I knew people who'd worked on the same aircraft all their working life.
Yeah.
I don't think I could have done it, but I admire them having done that. And then you get sort of like the extreme end of that is you get the NASA space probes that are now out, Voyager 1 and 2 outside the solar system. I was reading the other day that they've just turned on a particular attitude engine which has been dormant for 37 years,
Wow.
unused for that whole time.
Yeah.
Sent it the signal, wake up, we need to do some manoeuvring, and it worked.
Right. Wow.
That is fantastic.
Yeah, that's amazing.
So engineering, I love that.
So just on that, so
Yes.
so you've so a lot of engineers are not they are mathematicians, but they sort of, the maths people kind of look down a little bit on the engineers.
Sure.
Because they're not the sort of
They're
theoretical.
making
They
wings
make,
or whatever,
but this is the interesting thing, like, because we were talking earlier about mathematics and context. Well, actually, engineering is the ideal mathematics with context, because you've got to build something or respond to something that's working. So I find that very interesting. Did the context help you?
Yes,
to love engineering?
Yeah. And the fact, as a kid, you think, oh, wow, wouldn't it be nice? And because I remember as a child seeing the old Lightning aircraft taking off from Norfolk airfields. And now, of course, we've got the P-38 Lightning II, which I also did some software work on, which is a kind of stealth aircraft and vertical takeoff and worlds apart from that original Lightning. And yet, obviously, it works on fundamentally the same principles. It's a thing that has to go up into the air and stay there safely and come down again. There was a sort of slight childhood kind of, I'm fulfilling a childhood dream sort of thing here.
Well, we all had planes and cars on our walls,
And having kind of dodgy eyesight, I realised at quite a young age I was never going to be a pilot.
Right.
So this was a kind of one step removed. I'm actually working on the planes.
So one of the bits that I'm very keen to talk about, and I've deliberately kept it back a little bit because it's the bit that really interests me, is about the AI. So you worked on AI in around between 1997 and 2001. So I'm fascinated to understand, I think you've given me an insight before, but I'm fascinated to delve a little bit deeper. So AI in the 90s versus AI now, similar, different? What are the differences? What are the similarities that we've got?
1997 to 2001 was when I was with a small AI firm.
Right.
Did some work with Met Office for weather prediction and stuff like that. And then I actually carried on through the aerospace work. So probably for another 5, 6, 7 years after that was all actually AI work. So in terms, for buzzwords, in case people are familiar, I worked on neural networks. Both what they call supervised, which is where you have a sense of what the answer is. So if you're training your system to recognise digits 1 to 0, so 1 up to 9 and 0. So you say, here's a pattern, this is a 5. Here's a pattern, this is an 8, and so on. Or unsupervised, where you're saying, well, I'm looking for things which are like each other, but I don't quite know what they are. So you often get that with health monitoring, for example, or machine health monitoring, the same thing. This is a normal pattern, this is an abnormal pattern. I don't quite know why it's abnormal yet, but it's out of the group on its own somewhere. So neural networks, and also the thing called fuzzy logic, which I thought was brilliant, and sadly has rather dropped out of favour now. Fuzzy logic was an attempt, rather than say things can be either true or false, you give a confidence. You say, well, I'm pretty sure about this, or I'm very doubtful about that.
Right.
So it's a bit more of a kind of a grey scale, hence fuzzy.
Right.
Rather than just yes or no. And also it attempted to deal with things like missing data or noisy data. We all know that in any system at all, business or engineering, the data you get is often questionable quality.
Yeah. And that's a commercial problem. Lots of businesses face that with
Definitely.
data. And when you're trying to do things with data, if the data that's provided by the company is not very good, it's very hard to do something substantial, or do something worthwhile with.
So with fuzzy logic, you could say, I'm pretty sure that this number is right, but I'm very doubtful about this one.
So it's interesting. So something I've talked about is like user research, and in some of the scales when you're asking questions, you can ask, "Are you very sure? Are you sure? Neutral? Not sure? But unsure." Is it that sort of scale that you'd sort of?
It was really.
So did it ever evolve into like I am 70% sure this is right? I'm 10% sure this is right.
Probably not that accurate. You're going to give qualitative things.
Right.
Like uncertain, quite sure.
Yeah.
The other thing that we used fuzzy logic for was, where we got these situations, like I say, you have normal behaviour and then something out of the ordinary. Then fuzzy logic was a way of saying, well, can we understand why it's different? What's the driver that's pushing this thing out of the ordinary?
Yeah.
As I say, I didn't see much talk about fuzzy logic these days, which I think is a shame because I thought it was very cool. So that was the technical areas I worked on with AI. How is it different now? Well, back in those days, it was all desktop stuff. We had little networks, but it was the very, very early days of being able to actually do things on a network meaningfully.
Yeah.
So you brought your data to your laptop or desktop, whatever it was.
Yeah.
You ran a program on your desktop with the numbers, so it might be a CSV file or Excel or a database, whatever it is, but you had to bring it all onto your machine.
Yeah.
And of course, you have a capacity problem. I had problems where you'd be working on it, everything was fine, and then you'd run out of memory.
Right.
Game over. Yeah.
and I think that's what we touched on when we had this conversation separately, is the capacity and the speed that we now have in comparison is hugely different, isn't it?
So for a start, your laptop you've got.
So sorry to cut across you. So are you saying that the actual AI has not necessarily changed?
We'll come on to that.
Right. Okay.
The real substantial difference is where it all happens. So the model now is that the data you're dealing with is typically huge. We used to deal with little toy problems. The very traditional problem that's used in statistics and AI research, everything, of classifying particular kinds of flowers, iris flowers, by certain measurements. And you have a data set of like 150 things, and you split them up, and it's a good test bed for saying, is my new algorithm any better or any worse than someone else's previous one? Used a great deal for different things.
And was that from photographs, or was that from actual measurements from
right?
Yeah.
Anyone who's come across Fisher iris problem will recognise all this.
Okay.
But typically in a real world problem, you may have hundreds of thousands, you may have tens of millions of points. There's the by reputation at least, the Chinese face recognition system, which is dealing with billions of people. Now you cannot put that data on your desktop.
Yeah.
So the paradigm has shifted to you take the processing algorithm to the data.
Yeah.
Because your algorithm itself will probably be quite a modest program in terms of numbers of lines of code. It might be an applet or a database widget or something like that. Mm-hmm. But whatever it is, you take that processing and you put it where the data is, because the data is the big thing.
Yes.
So there are lots and lots of tools now where you can put you can, let's say you've got, I don't know, a SQL Server database, whatever it is, and you can run your AI algorithm inside the database.
Yeah.
So you've immediately got processing power of a server scale machine rather than a desktop machine, and you're not moving data all the time over wires or wireless or whatever it might be. That's an enormous shift and has made possible a lot of the other spin-off developments from AI that have happened. As regards to the algorithms themselves, I mean, I see fundamentally many of the same names crop up. Oh, look, there's a k-means one again. All this kind of stuff. You think, I remember that one. But being deployed into a different context so that it can do its work on vast data systems rather than small ones. So something that's definitely changed, which again we'll move on to something I know you want to talk about later, is with the scale of data that we have and how we're able to deal with it, it means that we can deal with things like natural language processing.
Yeah.
which you could do in a very rudimentary sense years ago, but you couldn't do it very successfully. And now, as we all know, there are lots of kind of domestic devices which will do that for you, which we're going to come back to later.
Yeah.
So some of those have required new kinds of algorithm. So you get probabilistic models, things called Markov processes, which are deep maths. It's the kind of stuff I used in theoretical physics years ago. I would need to brush up on it if I was actually working on that. And I think one of the things that has come of fruition is the idea of kind of pre-built widgets that you can slot into place. Now, back in the 90s and the early 2000s, I worked on kind of frameworks, a little bit like any framework we have. Like you're using GarageBand at the minute, where you can drag and drop different components into a workspace. Yeah. So we had it where you could drag a data source and a neural network and a processing module and a graph module, connect them all up with sort of join the dots sort of thing. Away you go. And that was, a lot of people were working on that. It was a very obvious idea to do. I think where that's come of fruition is that you can then say, right, I have my database or my my NoSQL data source, whatever it is, however big it is, and I have a neural network module or this module or that module, and I can do the join the dots inside the database. So it's the same kind of principle, but being leveraged in a very different way.
Right. So one of the things that a lot of people read about is when computers get trained to play chess and play Go and things like that, and that's something I know we'd sort of dumbing it down just for my benefit. But so the actual process of teaching through using AI, is that basically the same? Because the difference. It used to be huge databases of data, and then you teach them how to play using that database. But now with the modern conception of AI, it trains itself, it plays itself to work out what the different scenarios are in each of those different solutions. Is that substantially different, or is it just it's used in a different way now?
A bit of both, I think. You basically get two kinds of intelligence system. One is where you train it in advance, you give it all of the training data and it does stuff, learns patterns, and then you, as it were, freeze it. You say, here's my trained system, I'm then going to use it, so I'm going to predict the number of, we mustn't call them Boris bikes anymore, must we? But whatever the bikes are called in London these days. Yeah. How many will I need on a particular day given the weather forecast, and this and that and the other? Yeah. I have trained my model on historical data, I'm going to use it on real data. Yeah. And normally you have within that a kind of review, let's say monthly or something, is it still working, is it up to date? Yeah. But fundamentally you train a system and then you use it. The other kind of system is much more like our own intelligence, which is where it goes on learning. Yeah. So it's learned a pattern up to, April the 26th. Some new data comes in, what can it do on April the 27th, and so on. Now, in the regulatory space, like aerospace, when you look at the various aviation authorities, they don't like that second kind, because what they want is to qualify a system. They need to know that it will produce essentially the same result given the same data. Now, a person doesn't do that. Tomorrow, I made you a cup of tea earlier. You said I have tea. Tomorrow you might say I have coffee. The situation exactly the same. Your preference has changed. As useless if you've got a system that is qualified on a safety level. So the idea of a trained system which then is deployed appeals to regulatory bodies, because they can then test it however they like, qualify on all kinds of weird and wonderful data, and then say, yes, tick a box, it's passed, go off and use it.
But that loses the human element.
Yes, exactly. And it also means that if genuinely new situations come along that the system has not seen before, what's it going to do? Well, it's going to fall back to one of its actions, but it's probably the wrong one. Let's say you've trained your flight control system with up to 100 aircraft, because that was twice your capacity at one time. Yeah. And then 5 years go by and you think, gosh, I've got 150 aircraft. What is it going to do? And really, you don't know. Yeah. That's a very simple example, but you get the point that one of the characteristics of intelligence as we recognise it in people, is that they can adapt to new situations, new data, new things that they hadn't expected.
Yeah.
And for that, you need some kind of AI model that will go on learning.
Yeah.
Ideally, without forgetting what it has before.
Yeah.
There's an example we used to use. I worked on one of these models. That if you imagine an infant and they drink liquid out of a feeding cup. It has two handles, it has a little thing on the top and a little kind of teat thing that they drink through.
Yep.
That is their conception of a cup.
Yeah.
Now, as they get older, it changes. Maybe it only has one handle instead of two. It doesn't have the thing on top, the safety cap.
Yeah.
It might have a different pattern or a different shape. But something about that, they know it is still a cup. It's still right for drinking from.
Yep.
That's what you want of an AI system, to say, well, okay, I have gone from my feeding cup through to my horn flagon or whatever it is, and I still know it's something I can drink from.
Yeah.
Rather than forgetting what you did before. And that's the real challenge with AI. How do you learn on without forgetting?
And why is it again a storage? Like why is it an issue to remember for the AI system to remember what it did last week compared to what it does now?
Well, supposing you've got your idea of what's normal, you've got a clustering algorithm, so we would say, and there are a number of different ones of that. And I have a cluster of this is normal behaviour, this is abnormal behaviour.
Yeah.
Well, as time goes on, what happens? Do those clusters drift toward each other and become one? Do they fissure into separate ones? Do I still remember that what I thought at one stage was abnormal behaviour still is, or has it somehow been lost in a bit of a mess of noise?
Well, you make it going to the cup scenario.
Yeah.
So when I was a child, we call it a sippy cup, a sort of cup with the top on. My children have stopped using, but you would use that, and then you would as you say, evolve into a cup, a beaker, a tumbler, a glass, whatever. Now, when I was 20, no kids, socialising. That my thought of a cup was very much a teacup or a pint glass. Now, it's not until I was older and I had children that I actually then recognised again that sippy cups existed. Because in a way, I kind of had forgotten that they existed.
Perhaps, but if someone had given you a drink in a sippy cup,
known what it was.
You'd have known what it was.
Yeah,
You'd drunk. You might have thought, "This is a bit weird. What are they trying to say?" But you wouldn't have thought, "I don't know what this is for."
Yes,
you would have recognised its purpose. So in an AI
so the Go scenario, the Chinese game. So does the AI that learns how to play that extremely complicated game, does it have a finite knowledge base? Will it only understand it until it's switched, or is there a storage that of those thousands different scenarios, it will at one point forget / ignore or discard?
I don't believe. I mean, in the old days, I used to write chess programs, and back in the day, we used to write them by trying to do kind of huge tree things of every possible move, and then every possible next move, and every possible third move, and you very, very rapidly run out of space.
Right.
So the modern trend within gaming, as I understand it, is that you look for patterns. You don't try and do exhaustive tree searches of every possible combination, and you quickly recognise that a particular strategy, a particular pattern, is a losing one.
Right.
So if you like, in terms of your tree, you chop off branches as early as you possibly can.
Right.
Now, I don't know in detail how theirs works, but I'd be confident that it won't forget how to play Go unless you actually press the reset button. I imagine it's got a reset button.
Yeah.
But otherwise, it will maintain its knowledge. And again, my suspicion is that each and every game it plays, it will in some way enhance its experience and think, oh, actually that worked, or the opponent did this that I wasn't expecting, and it was a really good move.
But the interesting thing about the Go scenario is that it plays itself. It doesn't even play a database or another person. It actually it mimics two different players and two different scenarios that it plays against. So that in itself, I'm just fascinated. So it's understanding the different scenarios, and as you say, it's saying, well, in this scenario, we're not going to no one would choose these 3 options. There's another 2 options. We'll process those 2 because that is the preferred options of an experienced person. So I'm just interested. So is it a capacity thing? Are we still struggling, even though we now have gigabytes of data that is available to us? Are we still in a situation where capacity and speed is an issue?
Ultimately, yes, it will always be an issue. The big arena at the moment, as I understand, having effectively shown that AI, chess and Go machines can beat human masters, the big arena at the minute are the multiplayer online games.
Right.
Can an AI join in a multiplayer online game with thousands, tens of thousands, maybe millions of other players and play a creditable game? And as I understand it, that's where a lot of the interesting research is going on at the moment, because then the level of unpredictability and the possible multiple interactions with different players and alliances and all the rest of it. Whereas a one person against one person game, well, there are only 2 people. They are always automatically the adversary. Whereas in a multiplayer online game, some will be your adversaries, some will be your allies. They might change roles. So it's a very different kind of problem. But again, talking about the strategy for that.
But that's just thinking about how 4 people or 6 people would play rather than a one-on-one.
Yes, but the possibilities for play expand
hugely.
I want to make alliances with 5 of the 6, and will they let me? Because that's up to them. I think too, if you look at a chess program,
because it can't predict.
No, it can't predict
a human action, because a human action is not necessarily rational or thought through, or they might be instinctive. So.
And again, with that situation, the computer has access only to very limited visibility of the whole. With chess or Go, you can see the whole board. In principle, you can enumerate everything that everyone can do. When you get into situations of uncertainty where there's, if you like, a fog of war over the board, and you can only see your little corner, well, that's a hugely more difficult problem. Because it's no longer a matter of listing possibilities, but a matter of speculating about potentials.
Yes.
And that's part of the problem, the point I want to make about the chess and Go programs. They are brilliant at playing chess or Go. They are useless at having a conversation. And what another part of AI research looks at is how can we make something which may not be brilliant at everything, or may not be brilliant at any one thing, but is pretty good at a broad range of tasks, because that's what we expect of a person.
Yes.
We know that there are some people who are absolutely brilliant at X, Einstein or whatever. But most people are tolerably good at a wide range of things.
So it leads me on, because one of the things I did want to talk about AI, and we are going to move on, but slightly move on because we're going to talk about Alexa, but the idea that now computers can make assessments in the medical arena. To be able to, I think, was it last year that they actually found a strand of cancer which hadn't been discovered before, and the sort of working out the diagnosis side. Is that just because the body is very complex, very complicated? Are we going to find that the computer will be a lot better than a human in diagnosis or understanding of?
I think the computer, in an ideal world, it depends how it's been programmed. Ultimately, the computers of today will just do what they're told. But a doctor, by reason of their medical training, will look for particular sets of symptoms or indicative facts or things like that. Now, when you run a bunch of medical data through an AI program, then you can code in medical knowledge. You can say, well, I know that a temperature of 105 is pretty bad, or whatever it might be. But equally, you can go in with a kind of blank slate and say, well, just look for patterns here. Go in without any preconceptions of what you're looking for. And it's that sort of situation where potentially an AI algorithm will say, well, oh, look, we never realised that, twitching of the left foot was actually related to, I don't know, a seizure. Whatever. I guess what going on. But things that are not anticipated and are not routinely communicated as part of our medical training. But because the body is an interconnected system and a very complex one, I completely expect that there will be things like that, where there are unexpected indicative symptoms that a dispassionate algorithm might flag up.
So just on that, so I'm completely clear. Are we saying that a doctor of 30 years might approach a problem, and with that 30 years experience might come to a diagnosis of A, where a computer, because they don't have the bias of those 30 years, actually approaches the situation with a new, fresh outlook, and they would perform the diagnosis better than with a doctor of 30 years? Is that where we're at?
That's where we might go to, but right now the situation would be that if something like that was thrown up, if the computer said, measure the twitching of the left foot, then a lot of people would review that and say, well, is that an accidental find? Because you get things that are just a feature of limited data, accidents of what you happen to have chosen. So if the computer does throw up things like that, then you can bet your life that medical teams all over the world will assess that, and they'll either say, no, that was an accident of the input data, it's actually irrelevant, or, well, look, this is interesting, we hadn't thought of doing that before.
Yeah.
And you could be either of those, because some AI systems will be trained with a kind of some sort of knowledge of the human body and its normal and abnormal operation, or they might not.
Okay.
I think the trend is going to be to put as much prior information in there as possible, but aware that if you do that, you might be blinding yourself to things that we just don't know about. So it's very much a balancing act. And again, the commercial trend, you can bet your life that if an AI researcher had unlimited time and money, they would do it one way. If they're working in a business context where they're expected to do something within 6 months for a certain budget, they will do it slightly differently. So it's kind of,
So we've talked a lot about AI and how the sort of theoretical side that we talk. I want to touch on something that I know is one of your passions of recent times, is regarding Amazon Alexa. And I talked on a previous podcast that it's one of the potential pieces of technology which could really change people's lives. So I want to talk about two things. What do you do? What? Just a bit of background for understanding what the Alexa skills are, and then equally, I just want to talk a little bit about what you see the future for Alexa or Google Home or whatever person.
I'm going to talk about Amazon Alexa. It's the system that I know best. But obviously there is things like Google Home, there's
Apple have just got
Siri, there's Cortana, Samsung have got a thing called Bixby that I don't know anyone uses, but it is there.
It is there,
There are a lot of these around, and there are a lot of very special purpose ones developed often by university departments that you can only access online and are not a domestic device.
Right.
Alexa has managed to get us into a domestic or vehicle context staggeringly quickly. I've been working on Amazon Alexa, what we call skills, for almost as long as it's been possible to work on them.
And so skills are...
Skills are like apps. If you imagine you've got a new mobile phone, it's got a certain amount of built-in functionality, like it can make phone calls. Perish of thought.
But do we still do that?
And it can do this and can do that. And then you can go to the App Store or the Play Store, or whatever is your chosen platform, and you can think, I really want something which is a night sky planetarium. Okay, it's not part of my phone to start with, but I'm going to download it. I now have a dedicated piece of functionality which you don't have, perhaps. And some of them are games, some of them are utilities, some of them are fun, some of them are stupid, whatever. An Alexa skill is like an app. So you get your new Amazon Dot or whatever it might be. You can immediately talk to it and say, good morning Alexa, and you get an answer. What's the weather today? And if you input where you are, it'll say the weather in North London is kind of, pretty miserable.
Grey and cloudy.
Grey and cloudy.
Very used in England.
So you get a certain amount of functionality built in, and quite a lot. Amazon have been quite generous with what you can just do out of the box. But then you can go off to a particular part of the Amazon site, and it's now in about 12 languages. I think they've just added various Spanish-speaking countries.
Okay.
So you can then add on these skills, and that's what I write. They're basically particular special purpose things. I'm going to pick an example to be concrete about it. It's a space one because I kind of like space. Right now, NASA have a probe sitting on the Martian surface in an area, a plain area, as it were, rather than a mountainous one, which is taking all kinds of measurements. And in particular, it's sending back weather reports.
Right.
Now, NASA, being generous, have made this data feed available as a public data feed. So I thought, wouldn't it be cool to build an Alexa skill which then will read the current last, I think it's 10 days or 7 days data. So you can say, Alexa, what's the weather on Mars right now? Well, it's minus 50 degrees centigrade and the wind speed is this and the pressure is whatever and it's winter time. You think, okay, fine. A little bit different from North London. So now that's not something you get with Alexa out of the box. It's something that not many people would be interested in potentially. But you have a publicly available data source which NASA deploy into a web page. I happen to have taken that same data source and deployed it into an Alexa skill.
Right.
Of course, I'm vulnerable to that. If NASA shut off the data source or if they change the way it's formatted, then my skill stops working, but that's a maintenance job, it's a testing job. So then anybody who wishes can enable that skill for free. I don't charge for any of that stuff. Some people do. It's just a matter of what you're doing. I do it as a fun hobby, so I don't charge for it. And it's like an app on your phone, except it's something you speak with rather than anything else. And you get answered in Alexa's voice. I've only done it in English speaking, but if I'd done the translation into Spanish, you could ask Alexa in Spanish, what's the weather on Mars? And I'm not even going to guess what that is. And Alexa would reply in Spanish. Now, the beauty of the system from my point of view is that I do not have to do any work at all on the language comprehension. All of that is done by Amazon's cloud systems in what often goes by the name of a data lake, where basically they have stored umpteen gigabytes, probably much bigger than that, whatever the scale of data is, of speech patterns.
Okay.
So that when I say, Alexa, open Martian weather, and you say it, and somebody in India says it, and somebody in Canada says it, that data lake recognises what's being said and opens the right thing.
So does that mean that accents, so the Geordie accent or the Mancunian or even the Californian accent, Alexa is able to use all those different. So let me just think. So I'm gonna offend a lot of people in the UK, but let's just say the Geordie accent that does have slightly different words, slightly different meanings for words. If someone in Newcastle was asking for the temperature or the weather on Mars, but using slightly different, is it flexible enough?
To some degree, there's an envelope. You don't have to use the exact same words because it's intelligent enough to recognise an envelope around them. On the other hand, you stray too far from it, then Alexa will say, I'm sorry.
I just don't understand, Which when it first came out was incredibly frustrating. And actually that was, so one of the things that I think Google has a strength on is that it uses its search engine. Because I've actually got both. I actually ended up getting myself a little Google Home as well. And that's what I found initially with the Alexa was that you'd ask it something and it didn't have the skill available. That's improved, is improving all the time. But what Google Home did actually have straight away was, if I want to know, I don't know, I remember asking Alexa, however long ago it was, about the Six Nations rugby, and it really struggled because it didn't know when the fixtures were or who'd played who. Now they've probably got that it's just finished in February. I'm sure they've probably got that now, but you went to Google Home and you said to it, who's playing next Saturday in the Six Nations, and it would be able to reel it off. So I'm sure Alexa or Amazon will get better at that and will increase its knowledge.
Some of the most frustrating things is to do with music. There's a very funny YouTube video of which is kind of replaying the scene from 2001 where Dave Bowie is outside the ship trying to get back in through the doors.
Yes.
And, Alexa says, "Oh, I've got some music by the door." It's hilarious. I love it. It's undoubtedly true that at the moment the recognition is not as contextual. Now there are a number of very interesting decisions as to why that's the case. Amazon did not want their system to be too spooky. I know every now and again you get these things, Alexa spoke to me, the voice of my dead sister, or whatever. But Amazon made a deliberate choice to not be too spooky. So, therefore, by and large, different things you say to Alexa are completely disjoint from each other. So if you say, Alexa, watch the Six Nations, and Alexa will say, it's a rugby game between whatever countries.
Yeah.
Then if you say, who's playing next Saturday? Now a person would have no difficulty at all in saying, oh, England, Ireland, because they would know that that was the context.
Yeah.
Alexa does not retain that context by default. So if you say, who's playing next Saturday? Alexa will probably say, I don't understand what you're saying.
But the interesting thing, the great thing about what I've found about Alexa is, so one of my favourite artists, some people will know, some people will think, who the hell is this? Is Frank Turner. And I will say to it, check it out if you don't know, you might like it. You would say, can you play my favourite song by Frank Turner or favourite album by Frank Turner? Yeah. And it is able to contextualise, understand, you've played this song this number of times, this is obviously your favourite. I assume that's how they do it. Yeah. So in that sense, that's actually using sort of greater intelligence rather than just
using information that it's stored about your preferences over time.
Right.
I remember a mutual colleague of ours, his daughter was playing some music, and our mutual friend said, Alexa, that's crap. If we're allowed to use that word on the podcast. And
it's done now.
Alexa said, I've recorded your preference about this music. And then went on playing it anyway. So that is stored as part of your profile. Where it lacks context is, if I have a conversation with you, and we're talking about podcasts, and then I go off and make a cup of coffee, come back 10 minutes later, I say, when will it go out? You have no difficulty in picking up where we left off and saying next Tuesday or whatever it is. Yeah. You do that with Alexa and the context is lost. Now within the context of a skill, that context is retained all the time. So Alexa will know within the skill, if you've programmed it right, what you've said, what you haven't said, which bits you've heard, what you haven't heard, maybe suggests, you haven't heard about this yet. Once the skill ends, it's up to the programmer how much is retained for the next run.
Oh, right, okay.
So you can do something where somebody goes back to the skill the next day and Alexa will say, oh, welcome back, you asked me yesterday about this. Or not. It's up to the programmer. The programmer might have been lazy and thought, life's too short, who cares? In which case Alexa will say, yes, here's the skill. Yeah. It's entirely up to the programmer. And this, for me, is the exciting thing about Alexa, that you get these parts that Amazon provides for free, all the voice recognition. I do not have to try and understand Geordie accents and New Delhi accents and all the rest of it. I just send off the thing and say, this is what somebody has said. What do I think they're trying to ask me? Having got that, what we call the intent. So what the person says is the utterance. What the cloud system decides it means is the intent. Yeah. Obviously, it might get it wrong, might get it right. But with the intent, my programming is then responsible for saying, how am I going to respond to that? Am I going to respond to say, yes, the temperature on Mars is minus 50 degrees? Or am I going to say, get back to work, you lazy slacker? I could do either. That's up to me. So bits of the programming are entirely under my control, and bits of it are provided totally for free. And it's exactly the same with Siri and all the others. It makes it, for me, an extremely exciting field to work in because I don't have to worry about the bits that are really boring. Right. Fundamentally, storing shed loads of data of different people saying the same thing is really boring. I don't want to have to do that. I want to do the exciting bit of saying, let's look up the temperature or whatever it might be.
So what do you see the future for these consumer led or consumer based AI, so Alexa and Siri, etc.?
The big thing that everybody wants until they experience it is for Alexa Mark II to be able to join in a conversation as a person would. Let's say that you and your wife and your two kids, whatever, sitting around a table, then as part of the conversation, any one of the four of you might be silent for a while and then say something for a while. At the moment with Alexa, it's very much, it's like the old Star Trek model. Computer, will you do this for me? And then the computer leaps into life and says, not till next week, Captain. So what Alexa cannot do, deliberately by Amazon's choice, is preemptively join in something.
Okay.
It's already quite spooky.
It needs to be triggered by the keyword. Yeah.
Now, people find it quite spooky when all of a sudden Alexa thinks that she's heard the keyword. And
We're
somebody
going to
says-
have problems if anyone is actually listening to this and they're listening to it on their phone or wherever, and they're very close to Alexa.
Indeed.
And we've completely ruined their afternoon.
I've very carefully muted the one that I've got here. What Amazon have turned off is what we call push notifications. If you think on your phone, you get those little tray icons up at the top of your phone. At least it is on an Android, I imagine. Which tell you that an email has arrived or an alarm has gone off.
Yeah.
It's up to you then if you respond to that push notification or not.
Yeah.
Alexa does not have that, so I cannot, with an Alexa skill, wake up my Martian weather skill specifically at 10:40 tomorrow morning and say, "Hey Mark, the weather on Mars today is blah 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 blah." Obviously, an Amazon dock can set alarms, but you can't tie those into a skill. And Amazon have done that to avoid the semblance that Alexa is kind of snooping on people.
Yes.
However, for AI to become really integrated into a domestic place, it will have to happen, because otherwise.
Oh, really? Okay.
Otherwise, you've got this, you when you're talking with your family, you don't say, "Wife, tell me where you're going tomorrow morning."
Yes.
You just say, "Where are you going tomorrow morning?"
Yes.
So you don't have to use those trigger words, unless you're, one of your children's being naughty or something. So the fact that we have to use those trigger words signals the fact that Alexa is not clever enough to understand
when she needs to enter and when, right.
And it's that understanding of when to participate and when not to that is missing from all these systems.
Okay.
And I think if that could be cracked, and I'm absolutely convinced people are working on it,
Right.
that would be a big step forward, because then Alexa, or whatever the next generation is, becomes a colleague.
Yeah.
So.
Or a member of the family.
Or a member of the family. So in the work
yeah.
context, just to bring us back to work, you can easily imagine. So one of the things I was asked when I was at my former place of work is, could we have something that, we all know that you're supposed to get up every hour from your workplace and walk around and whatever. Could we have something where Alexa would say, "Mark, you haven't got up out of your chair for an hour and a half. It's about time you did that." And the answer is, right now, no, you can't, because that's a push notification.
Right.
And yet, for this person to be an actual intelligent assistant, you want that. As well as saying things like, "Oh, you did say you were going to ring Fred tomorrow, or today, whenever it was." So all those kind of remindery things, which a phone can do really, really well, Alexa can't do, and the other similar technologies. So to be a real assistant in the workplace or in the domestic space, you have to have that.
Yeah.
And to overcome the barrier, kind of, why is she joining the conversation?
But it's interesting, the whole sort of chatbot, which has sort of gone into lots of different industries like travel and banking and whatever. That's always triggered by you entering the website or you entering the system. So always there is a trigger movement of, I need you to answer my question now, and that's going to be quite difficult for
you get a little bit more flexibility with that, because you can, if there's, let's say, suppose someone's been staring at the page for 2 minutes, then your chatbot has the liberty to say, "I wonder if you're stuck trying to find something, can I help you? This is what I can do." So the chatbot can intervene a little bit, but you're absolutely right, the chatbot fundamentally is linked to you going to the page, whatever it might be. But it has a little bit more flexibility than Alexa, in the sense of being able to respond to delays, or to, you click 3 times in different places, what is it you're trying to do, can I help you? Chatbots have a little bit more flexibility, but still not very much. Some of that is it's hard to program, it's time consuming to program.
Okay. My last question, which I just want to talk to you about, is, so you made a choice, you can go into as much detail as you like, about moving to the Lake District for initially a year to work with your son and his businesses. So how's that going? Are you finding it must be a real different challenge?
It is, yeah. I mean, you mentioned earlier about me working in lots of industries. I worked in engineering, as we talked about. I then worked in various financial services where, speaking frankly, there isn't the same commitment to long-term quality. It was quite a shock to me going into my first job in finance where there was the expectation that a bit of software might last a year if you're really lucky, and there was an expectation you would then throw it away and start again. I'm thinking, what, a year? A year is nothing, you know. Finance I always found a slightly strange environment for a techie, because the goals and the priorities are quite different from those that you adopt as a technical person.
Yeah.
And so there's more of a culture clash there.
Yeah.
At the moment there's a family business which has got several different components. I'm committed there for a year. If it continues to go well, then I'm committed there for longer. And basically my role is, I kind of laugh about it and say it's still a QA role. I do some IT, I do a lot of technical support for our various systems. I do some Alexa skills. But they're all focused around tourism in Cumbria, or things that are related, or they're fun things like weather on Mars. We don't yet have a Martian part of the business. Although if Elon Musk has his way, then
maybe that is the future, yeah.
But also a lot of very practical stuff, like we were mentioning before we started this podcast. We have a lot of casual labour. They have an entitlement to a certain amount of holiday, but they work very irregular hours, so there has to be some accommodation made from that. Automating those systems has been quite challenging and a lot of fun. We have situations where we have different suppliers that can provide essentially the same good, and they're always fiddling around with the prices. Can I write something which will basically scrape different websites, do a price comparison, say, well, this week you should buy from supplier A, next week you should buy from supplier B. So they're surprisingly complex problems for a small business. There must be problems that many small businesses face. And yet, you know, if you want an accounting package, no problem. There's Xero or any one of these ones out there, Sage. If you want stuff that actually does your monthly payroll end, well, if you've got casual labour, you're on your own.
Harder, isn't it? Yeah.
So I love it. It's fantastic. It's also, you know, because I've always been on the technical side, and the business side is always a little bit of a kind of weird place for me, and now I'm forced much more into contact with the business priorities. You know, do we want to spend time doing this? Yes or no? Not just, is it an interesting job?
Yeah.
But actually, in the summer, when our trade is higher, because we're a seasonal business, can we actually afford to do this bit of work, or should we put it off until November? So all those kind of businessy decisions and commercial ones are becoming much more part of my experience now, alongside the technical stuff.
So what's your ambition for the rest of your career?
Well, one of it is to get work-life balance right. You know, always in all the big firms I've worked for the last, 20 years, there's this whole, must get your work-life balance right. And obviously firms want you to err on the work side rather than the life side, for all the lip service that's paid. But actually within a small business, and this will probably resonate with a lot of your listeners, it's really, really hard to do. Within a big business, you get, so many days leave a year. You can.
But anyone running their own business, it's based on your results rather than the result of a team, a company, revenues or whatever. So
So finding that balance and being able to say, right, at this point, right now, I'm going to put down work and I'm going to do something fun. That's actually quite a hard thing to do. And that's in my first 6 months in this, I would say that I haven't got that balance right.
Okay.
The next 6 months is going to be trying to get it right so that the work still gets done, but other things get done alongside that.
So what we haven't touched on is your writing. So you do a blog, which I can put details of the blog on the show notes. I also understand you write a bit of fiction as well. So is the ambition to write more or do more Alexa, which would be your priority if you in the next 6 months?
I would like to do both. The writing, I write near future science fiction, and a lot of it, people would not be surprised after what I've said here, the kind of things I write about. I look at a situation sort of 70, 80, 90, 100 years' time when Alexa Mark 10, let's say, is there, of a level of sophistication where that could be a meaningful work partner.
Yeah.
I don't go into kind of sex bots and that kind of stuff because someone else can write about that. But I look at it in terms of having an artificial intelligence as a working partner.
Right.
And I also, because when I started writing this series, I was working very much in the financial services. A lot of it is about financial fraud, but in space.
Okay.
Which kind of, what things are different. If you're, on Earth, anywhere at all is within sort of about a quarter of a second, if you think of a signal going around the world.
Okay.
Now, if you've got, your base, let's say the NASA's Mars lander builds up into a big Mars base.
Yeah.
Now Mars is minimum 20 minutes away, maybe 40 minutes. A lot can happen in 20 to 40 minutes. So what are the kinds of financial fraud that might find avenues when all of a sudden signals are delayed again?
Right.
Because we're used to a situation where
with fibre optics, it's literally in less than a second and it moves.
It happens quicker than you can respond to.
Yeah.
And we see with electronic trading and automated trading how either well or how badly that can do, happening vastly quicker than a person can respond to.
Yeah.
So those are the issues I look at, kind of human AI interactions and how that will develop and that sort of thing. So that's going on. I'd like to do more of that. Blog, the blog kind of supports that. I write blogs about things that interest me, really. There isn't any one single theme. Sometimes I talk about ancient history, sometimes I talk about astronomy or rocketry, all kinds of stuff.
So just to wrap up, so if anyone wanted to find out more about you or interact with you, how would they do it? You can do a plug of your son's business in the Lake District as well if you want.
Yeah. Well, the business consists of 3 parts. There's a guest house they're all in Grasmere, which is a small village, pretty much bang in the geographic centre of the Lake District. It's very full of tourists at some times, so if you don't like tourists, you're better off coming slightly out of season. But it's a great place, love it. It's close to a lot of the very, very challenging and difficult walks that you hear about, but also close to a lot of very ordinary ones. So there's the guest house. What's
the guest house called?
Oh, Lakeview Country House.
Okay.
And we run a small pub/bar called The Good Sport, which is just down the road from that, which is a lot of fun. And for the pub, we brew our own range of beers. So most of the beers that we sell and ales and a couple of ciders are our own, and we make that in some old farm buildings just off at the edge of the property.
And so if they wanted to find you on social media, or as I say, I'll put the blog. I'll put the blog.
But we'll
blog
put the
posts.
links on the show notes. Be easy rather than sort of me saying www.
Yeah.
But they'll be on the show notes. That's where to find me in a business context, and we'll put a couple of links for that. So it's all good stuff.
Awesome. So we're going to wrap up there. I'm just going to do a quick wrap up for everyone. So if this is the Absolute Business Mindset podcast. You can find this podcast on all platforms on where podcasts are released. I've got an active Instagram and Twitter account, which you'll get on the show notes as well. I've just set up a Patreon account, so if anyone wants to join, and there's different tiers on there that you can get different support and different sort of merchandise and stuff. And obviously there's also the YouTube video, which has all of my videos and from quite a long time ago. If you listen to any of them, please give me a thumbs up. That would be very much appreciated. All right, guys, thank you very much for your time, and I'll speak to you soon. Thanks. Bye.